Hey everybody, it's Kevin Dewalt of Prolego. As you start developing your enterprise strategy for large language models and generative AI, you're going to run across terms like embeddings and vector databases. And I was trying to find an example of where these terms are explained for a business audience without all the data science jargon, and I just couldn't find anyone, so I decided to make one myself. So here it is. Today I'm going to talk about embeddings. I'm going to describe what embeddings are, why they're relevant, what they can do, and some examples of how you might use them in the enterprise. So, what are embeddings? Well, it turns out computers are not good at working with unstructured text documents, natural language, the things we say and write and read. Instead, they need a series of numbers. Embeddings allow us to take unstructured text, convert them into numbers in a way that computers can use based on the underlying meaning in the text. And that last part is critical because it's trivially easy to convert text to numbers. I mean, you can just make a different number for every word and you're done. But that doesn't preserve the meaning in the underlying text. And this is where embeddings really come to shine. So the best way for me to explain this is to use a really simple example from children's nursery rhymes. So let's take two sentences. Sentence 1, Mary had a little lamb. And sentence 2, the cow jumped over the moon. Now let's take these two sentences and let's split them into 4 total chunks. So chunk 1 is Mary had. Chunk 2 is a little lamb. Chunk 3 is the cow, and chunk 4 is jumped over the moon. So just stop for a second and think about these 4 chunks and try to ask yourself, based on the probable meaning of these 2 sentences and how English language is normally used, which chunks are the closest in meanings? So I would imagine if you took all 4 chunks and you plotted them on a 2x2 graph, you could visually see which ones are the closest. And I have an example in the blog post associated with this video where I do just that. But I think you can kind of understand it from my explanation. And when you do that, you would expect that a little lamb and the cow to be the closest in physical location based on meaning. And that's because normally when we talk about these 2 chunks of text, they're in the context of like animals, especially on a farm, right? Domesticated animals, right? So we would assume that they'd be closest. But let's just now assume that these 2 sentences were part of a larger story where there's an intelligent cow named Mary. Now suddenly the context and the meaning of the text changes. Now we have Mary and cow are likely to be the closest one in our 2x2 grid because that makes sense given the environment. So that's why embeddings are powerful. Now you can take the same logic and imagine applying it to all the unstructured data in your enterprise. That can be documents or PDFs, customer conversations, rules that you have. And you can allow you to split them into chunks and begin processing them based on relative meaning, especially when you apply them to other sources of data. So let me just give an example from some of our client work. Let's suppose for a second that you are the compliance officer in a bank and you've got all these different policies and procedures associated with how your compliance operation works. What people can do, what they can't do, what they can say and when. Now the SEC comes out with a new rule or a proposed new rule and you're wondering, oh my gosh, how do I find the area in all these compliance documents that were written over years that are most relevant for this rule? Well, embeddings and the use of large language models are a great solution to this problem. You can imagine taking all of your compliance documents and the SEC's rules and splitting them up into a set of embeddings. And then you can take the embeddings from the rules and match them against the embeddings from your compliance documents and find the ones that are closest related. If you then pass this information into a reasoning large language model like GPT-4, it can process through the information and make recommendations for how your compliance information should change. So that's an example of how embeddings are useful. I hope this helped you understand what embeddings are, what they can do, and how you can apply them to your LLM strategy. Have a great day.